Hello everybody and welcome to another math video. In this video we're going to look at these enVision's Algebra 2 topic 5. We're going to look at two different examples because we're going to rationalize our denominator, and I'm going to go through two different examples or two different ways to do this. So what is the cubed root of 2n minus 9 in reduced rational form or radical form? Once we work through this, we're going to have a radical in our denominator. In Algebra 2, we don't want that. We want our denominators to be clean. So we're going to do what's called rationalizing the denominator. So to rationalize the denominator of an expression, you're going to rewrite it so that there are no radicals in any denominator or no denominators in any radicals. Basically, you want that denominator to be a clean number. So let me go over to my notebook. Let's start working this. Okay, if you remember back in the concept check, we learned, not the two, I'm going to use A and B, that if I have a radical, it was A over B, I wrote B over A for no reason at all, we can break this apart. We can expand this radical, this quotient of radicals, into the n root of A over the n root of B over the n root of A. So now I'm going to use this property to solve this equation. Actually, it's an expression. So this is 2n divided by 9m. All right, so breaking this apart, expanding this, I'm going to have the cubed root of 2n divided by the cubed root of 9m. Looking at this, we have a radical in the denominator, and I don't want this radical in the denominator. One thing that I know is that for me to make this radical into a non-radical number is that I need this to be a perfect cube. I need this, let me write this in blue, to be a perfect cube. So what I have to do here is I have to think of values that I can multiply to 9m to make it a perfect cube. The one thing that I know is that 9 consists of 3 squared. And since I already have a base that's squared, then that makes this a little bit simpler. That means I'm not doing 9 times 9 squared to get that 9 cubed. All I have to do is multiply this 3 squared by another 3 to get 3 cubed. We do this in a different color. I'm going to choose this purple. So 3 squared times 3 will give us 3 cubed. M in this case, m is to the power of 1. So we need to figure out what we need to multiply m to get m to the power of 3. So 3 minus 1, that will give us m squared. And the whole reason I did this is now I have created a perfect cube. As a matter of fact, I could say this is 3m cubed. Knowing that, I now am going to rationalize my denominator by using this fact to eliminate this radical on the denominator. So 2n divided by 3 squared m, and I'm going to multiply. And I'm going to multiply it by this purple number. So remember back in the same concept that for me to multiply any number within the radical, I have to have the same index. And in my case here, I don't even have a radical. And so at this point, I cannot multiply this value with this value. So to solve that, I'm going to make this a cube root. Now I'm able to multiply the numbers within the radical. Okay, so we know from our work above we will now have 3m cubed, which takes care of this cubed root. Okay, and I'm just focusing on the denominator. I know I can multiply this numerator out, but I want to just focus on this in parts, just to ensure that I'm not making any major mistakes. Because if you notice, I left this out at the beginning because I was really just focusing on the denominator. All right, so now I don't have a radical in my denominator. I move that radical from the denominator onto the numerator. And looking at this, I have the same index value, the index value of 3, which now means I can multiply the values within the radical. So 2 times 3 is 6. I'm going to go on alphabetical order, m squared, then n, divided by 3m. Because this is in the radical, I cannot divide out that 6. This would be my final answer. I have rationalized the denominator for this one. Okay, so this is a binomial. This is rationalizing with a binomial. It's not too bad. You just need to make that perfect index number. What happens if this is a monomial? What happens if I go to a binomial? So how can we write 1 over 2x plus the square root of 5 without a radical in the denominator? Okay, I'm going to go back to another topic where we talked about conjugates. So if you remember conjugates, a conjugate is a plus b times a minus b. We see this in difference of squares. We saw this in complex conjugates when we were working with complex numbers. We see that when I have something like this, I am left with a squared minus b squared. And I'm going to use this to eliminate, to manipulate that denominator into a number rather than a radical. So I'm going to have 1 over, and this is a binomial because there's 2 terms. And so what I'm going to do now is I'm going to use this conjugate. If this is 2 plus root 5, I'm going to multiply this by 2 minus root 5. And again, what you do to the denominator, you must do to the numerator. Looking at my conjugate, I have a squared minus b squared. So my a in this case is 2. 2 squared is going to be 4. Minus b squared, which is root 5 squared. Over 1 times that, so 2 minus root 5. Okay, root 5 squared is just 5. So 2 minus root 5 over 4 minus 5. And 4 minus 5 is negative 1. So 2 minus root 5 divided by negative 1. This is not the best way to write this. I could go a little bit further, so I am. I'm going to pull this negative to the front. Anything divided by 1 is itself. So I'm going to distribute that negative, and I'm left with root 5 minus 2. And this is my final answer. I don't even have a denominator anymore. When we rationalized that denominator, we got rid of the denominator. So now we have root 5 minus 2. So let's go look at this example 6 and see if there's a second one here. Nope, that's the only one. And they do explain to you the rationalization of the denominator that has a binomial, which is 2 terms. You must multiply it by the conjugate. So know that conjugate, know the difference of squares, know the complex conjugate, know that this shows up over and over again. All right, so once you multiply it through, you get our final answer, root 2 of 5. So the product of conjugates is always a squared minus b squared. Knowing that helps you go through these problems a little bit quicker. All right, so there you go. There is rationalizing the denominator in both a monomial and binomial examples. I will see you guys in the next video, and I hope that this was helpful.